In this video, we're going to talk about inheritance primarily, which is an attribute we use in object-oriented programming. But first, I wanted to talk about classes in general. So the first thing to say is, if you are creating more than one class, if we were doing this in Pycharm or something not Google Colab, we would have to create all those classes within one program, or better, save them out as a module and import them in, which is a separate .py file, okay? But when we're using Colab, we can just use separate program or separate code blocks to do our classes. So in this case, I've got just a dumb one, a class 1 and a class 2. Those, if you notice, are in different code blocks, the little code plus code here, okay? So down here in the test, I'm able to get to both of those without importing because they're all in the same window, okay? Keep in mind, though, that you have to run all of the classes before you can run anything that calls them, okay? So if you make a change to class 1, you would have to run that before that change would be reflected back into your code. So it's a good idea to run them all as you go down, okay? So now to the topic of the day, and that's on inheritance, okay? So this is one of the reasons that object-oriented programming has become so popular. It gives us the ability to recreate objects quickly. So we can take advantage of this idea of generalization or specialization, I guess is really what we're doing, okay? So we can define a general concept such as a vehicle, okay? We can then specialize that. So we make a vehicle class. The vehicle class would contain all of the things that vehicles have, okay? We would then specialize that into, say, a car, okay? The car, we would say, would inherit from vehicle. It would be a subclass of vehicle, okay? The vehicle class would then have additional information or additional features that a vehicle wouldn't have, okay? You could also specialize it into a truck or whatever you want, okay? So when we're talking about specialization, the word we use is, it has an is-a relationship. So a car is a vehicle, a poodle is a dog, and a square is a rectangle, okay? So whenever you have that relationship, you can use inheritance. So the example from the book, and we'll run through it here, it starts with the automobile class. So this is going to be just a generic automobile, nothing in particular about it, okay? So for this, we have our class automobile. We're going to have make, model, mileage, and price are going to be the 4 attributes that we're going to keep track of. We want to make them private, so we put an underscore there. One thing I will say, some of you ran into trouble. The init function has to be named underscore init underscore. Okay, if you don't have the double underscores at the beginning and the end, it's not going to work for you. Okay, so we always send the self. In this case, we're going to send the make, model, mileage, and price. Okay, we're then just setting those equal to those values. We then have our accessors, which just return that value. Then we have the mutators, which make it change that value, assuming we want them all to change, okay? The other thing that I've seen people do that's an error, when I go to create an object, okay, our init file requires 4 attributes to be sent. So even if you're going to allow the user to set those up themselves, you still have to send something, okay, to them, okay? So in this case, I'm just sending that stuff there, okay? And then to test it, you see when I run this, and I'm printing out on the get make from my A1, it does correctly pull from there, okay? So that's your basic class. So now I want to derive a class, as we would say. So I'll move it up to here. So this time I'm going to make a class car, okay? It's going to be a subclass of automobile. It's going to inherit from that, okay? So automobile is a superclass, car will become the subclass, okay? And that's a specialization. For it to be a specialization, I have to add something else, okay? There have to be other data items, okay? In this case, it's a simple example. All we're going to add to it is a door, how many doors it has. That's it, okay? So we're going to have all the others already because it is an automobile, but now we're going to add new stuff. So the way to do this, do a class car, parentheses this time, automobile, okay? Which will then pull up from this automobile class. Again, that has to have been ran before any of this is going to work, okay? So when I define this class, it has to, as always, have an init function. Once I find the home keys. Okay, which takes a self as always. We're going to have to make an automobile of this. So I'm still going to need the make. I'm going to need the model, need the mileage, we're going to need the price. I'm also going to need the doors. Okay. So that's what all it's going to take. So I can't directly set up the make or the model because those belong to the automobile. What I can instead do is call the superclasses a init function. So that's the first thing I have to do. Okay. Always going to do this. Going to call the superclass, which in this case is automobile. The superclass is init and send it that stuff. Okay. So to do that, I'm just going to say automobile dot underscore underscore init underscore underscore, call that init function. Okay. Always has a self there. I'm going to take the make that I've already included when I make this function. The make's going to go there. The model will go next, the mileage, and finally the price. Okay. So at that point, it's going to go ahead and make car an automobile as well, because a car is an automobile. Okay. So once I've done that, I only have to deal with whatever's different. Okay. So I'm going to deal with different attributes. Okay. So I'm going to have a function there, just like we do normally, self dot underscore underscore doors. That's the only variable we haven't defined yet, is equal to doors. Okay. So just so we're clear, when we create an instance of this, of a car, we have to send along the make, the model, the mileage, the price, and the number of doors. Okay. We're then going to call the automobile's init function. We're going to send it the make, the model, the mileage, and the price. Let it deal with all of that. Okay. We're then going to just deal with the doors because that's all that we have left. Okay. So beyond that, okay, we have to create a mutator function, or create an accessor first, what I always do. The book does it the other way around. Our accessor, we're going to find get doors self. It's going to return self dot underscore underscore doors. So we need there. Okay, we're going to have our mutator set doors. If that's something you want to happen, maybe you don't want it to be able to set doors, but if you do, it would look like this. That's not what it is. It would be self dot underscore underscore doors equals doors. Okay. So that's all done. If there were other attributes or other functions that you needed, you could add them here. But this is all we need, okay, as far as that goes. Okay. So now let's go through our test program, make it a little more complicated here. So if we were doing this in a normal situation, okay, we would have to import in these classes. But since we're all the same thing, we can do that. Okay. So in this case, I'm going to do the following. Just get rid of all this. Okay, I'm going to say used car. And again, I would normally do, let's just do it. Let's do it right. Do our main. I sometimes get in a hurry on these videos and make a mistake. Again, you should have more comments than I have. Okay. So I'm going to say used car is equal to automobile dot car, and whatever we want for the car. Okay, we have to go through and take care of that stuff. Okay. So let's see. Oh, the book changes on us. That's very interesting. I'm trying to follow the book's example. which is strange. It uses a class that doesn't exist, but it should still work out okay. They switched to vehicles instead of automobile, which is a better example, a better name anyway. So I wish I would have done that from the start. Okay. So we're going to create this. We're going to call this, using their example, an Audi. Okay. So they've got things in a different order. Make, oh no, that must be the model. Okay. They've got, the model must be a 2007. Is that the year? Is that the main? I thought that meant like which model. I don't know. The mileage, they've got 12,500. Price is 21,500.00, making a float, and then a 4 for the number of doors. Okay. That's all we're doing there. Okay. Again, we're going to do this class first. Make sure it's okay. Do this class. Make sure it's okay. Now I'm going to try this. Okay. Doesn't like something. What doesn't it like? That's what I thought. I'm not sure where that's coming from. It's very strange. I don't see their vehicles. Oh, that must be the module it's in. I should just be able to do this. Yeah, that's what I thought. That makes more sense. Yeah, the book does something weird and they put it into a module, which we don't need. Okay, so I've created a car now, my used car. Okay, just like this. Okay, so if I then want to go through and test things out, okay, I can do the following. I can say print used car dot get make. Okay, so all these are fine. Get make is now legit. Right. So when I do this, test it, make sure it works. And it does. Okay, so see what it's doing here. I've just created a car. It's the car that calls the that knows it's an automobile through this line and through this where it does the init. Okay, so when I call get make, it's calling get make, the one up here. Okay, so there's not multiple versions. Okay, it's only one version. Okay, and I can do the same thing for all those, but I can also do the used car dot get doors. Okay, and that will work as well. Okay, so again, you could make a class for that, or make a class for trucks if you want, that would inherit. And again, making automobile vehicle may be a better way to go about it. But you could add whatever trucks would have differently. Okay, so trucks have a drive type in the example from the book. Okay, so you can certainly add that, or you can add an SUV class. You can add all kinds of things. Okay, as far as our UML diagrams, right? We have our UML class diagrams. Okay, and let's see if I can find an example. Basically, automobile, you typically would draw that in its normal UML class diagram on top. It's normal little rectangle that we do. Okay, and then to show this inheritance, we put an open triangle. Okay, just make a triangle that's open with the point facing up. Okay, we then would extend lines from that to go to whatever inherits from that. Okay, which should be pretty basic to do. Okay, wonder if I could actually do a drawing here real quick. Let's see if I can, because why not? Is there a drawing option? This may turn out to be a very bad idea, but let's try it. Okay, so here would be our normal, our class definition. Why is it not letting me draw? It's just be automobile. Okay. And then of course we would have the other two parts of that would be for the attributes. Okay. then the methods. Okay, so I'm going to make a copy of all of that. And then the example we just did, we would have the car class here. Okay. And again, we would show how this works by putting in a rect or a triangle there. Okay. And then I would draw a line down to there. Okay. So that shows the automobile class. And again, this would have, the make, all that would go here. Okay. Have to format that properly. Like that. Okay. And then here you would have at least the underscore init underscore with all that stuff. Dot, dot, dot. Okay. Then the car would only have what's different. So the car would have the only member data it has is doors. Okay. And then the only functions, only methods that it would have would be the accessors and mutators for that. Okay, so that would be the get doors. Okay, which doesn't really take anything. And we would have the set doors, which takes. Okay. And again, I would want to fix that alignment. Okay, so that's all you're adding. So again, that's in a UML diagram, how we would show inheritance. Okay, and the inheritance is always and is a relationship. Okay, so if your sentence makes sense, then your code probably makes sense. So you say that a car is a automobile, then we're good. Okay, so that's inheritance. So we'll look at some examples in class, and we'll go from there. So if you have questions, make sure that you let me know.